Okay, dear friends, another question. A car is traveling at a speed of 60 km per hour on a section of a national highway having a downward gradient of 2%. Downward gradient means it is a downfall. ठीक है, slope है in the downward direction. The driver of the car suddenly observes a stopped vehicle on the car path at a distance 130 meter ahead and applies brake. If the brake efficiency is 60%, coefficient of friction is 0.7, driver's reaction time is 2.5 seconds, and acceleration due to gravity 9.81 meter per second square. Distance in meters required by the driver to bring the car to a safe stop lies in the range of. So friends, they have asked us basically stopping side distance. Okay, SSD they have asked, and what data they have given, just let us note down. Okay, so they have given the velocity. See, velocity they have given. So velocity is 60 km per hour. So here we will quickly convert it into meter per second. So 60,000 divided by 3600, it is 16.67. Okay, 16.67 meter per second, right? Then they have given us downward gradient. So downward gradient n, that is 2%. So we will take minus 2% basically. Okay, because it is in downward gradient means the vehicle is moving like this. Okay, in downward direction. This is the movement of vehicle. So that is downward gradient. The driver of the car suddenly observes a stopped vehicle on the car path at distance 130 meter ahead. Okay, so as such this is not required, because ultimately we have to find out stopping side distance. Just we will see what is the side distance. Before this we have to stop. ओके, स्टॉपिंग साइड डिस्टेंस का मतलब ही ये होता है कि जो भी ऑब्स्टेकल है उससे पहले हमको ब्रेक मारनी है. एंड अप्लाइज ब्रेक इफ द ब्रेक एफिशिएंसी इज 60%. नाउ सी दे हैव गिवन ब्रेक एफिशिएंसी of brake, basically it is 60%. So what does it mean? The efficiency of brake is 60%. Suppose if the brake efficiency is 100%, then skidding will occur. ठीक है, कि wheel lock हो जाएंगे. अगर 100% efficiency है, then wheel will, as soon as we are applying brake, the wheel will stop at that point only. Okay, so we don't want 100% efficiency. So okay, 60% brake efficiency is given. Another thing, coefficient of friction, that means value of F. So coefficient of friction F is equal to 0.7. Now see, we know that basically the value of F is equal to, it varies from 0.4 to 0.35, and it depends on the speed. That is, the speed ranges from 30 to 80 km per hour, because we know that F decreases with increase in speed. So many times if they are not giving the value of F, you can assume it as 0.35, but always remember this F value is the coefficient of friction in longitudinal direction. Okay, this is in longitudinal direction. Don't confuse it with longitudinal direction. Don't get confused with lateral direction, because that value F will be 0.15, which we will be using in super elevation, right? So this is lateral friction. So here we are not concerned with this, but this value is different. Lateral friction we are taking 0.15, and in longitudinal friction we are taking the value of F as 0.35 to 0.4 around. Okay, now see, basically many times you might be thinking that the friction value should be same whether in lateral direction or in longitudinal direction. See, suppose this vehicle is moving in this direction, wheels are moving in this direction, this is along the length. So in longitudinal direction, the value of f is different. But suppose it is moving due to super elevation or due to centrifugal force, suppose the wheels are moving laterally, right? So the value of f is different. So the main reason is that here we are taking slightly conservative value of f, because this f is equal to 0.15. Lateral skidding is more dangerous, right, as compared to longitudinal skidding. So that's why we are taking f value here 0.15. Otherwise, see, friction will be same only, but here just to have a conservative design, we are taking a value of f is equal to 0.15, so its contribution is less. So just to maintain that safety, that skidding in lateral direction is more dangerous as compared to skidding in the longitudinal direction. So that is the reason. Okay, so coming back to our question, here f value is 0.4 to 0.35. Another thing you can see what they have given, driver reaction time. So driver reaction time, IRC is also telling that t is equal to 2.5 second. This is standard. Even if they are not giving, then also we know the value of driver reaction time, t is equal to 2.5 second, and g is 9.81 meter per second square. Alright, so the distance required by the driver to bring the car to a safe stop lies in the range. So whatever question they have given, we have understood the question. I have noted down the given data. Okay, now just I will solve it quickly. So first of all, I will write the formula over here. SSD is equal to Vt plus V square by 2GF. Okay, this is the basic formula. Here also let me explain you this Vt is your lag distance, and V square by 2GF, it is known as braking distance. So let's understand some concept also, because it is also very important. So lag distance is Vt. Now lag distance basically depends on your PU theory, PIEV. We know that this is perception, intellection, emotion and volition. So whatever time is lost in these activities which are happening in our brain, okay, so due to that time loss, the vehicle will be moving with in its design speed. Okay, so that distance covered by the vehicle is known as lag distance. Now once we have realized that brake should be applied, then after applying the brake, then also the vehicle will be in movement. Okay, so that is known as braking distance. So basically there are two components, Vt is lag distance and V square by 2GF is your braking distance. Now again this same formula will be modified. SSD, that is topping side distance, or we can call it side distance also, both are same thing. So that is Vt plus V square by 2G F plus or minus n by 100. Suppose in case they have given us the gradient, okay, so suppose it is up gradient or ascending gradient, I am writing down plus n, we have to use plus n when ascending gradient, and we have to use minus n in descending or downward gradient. Is it clear? Okay, so SD is same thing, Vt plus V square by 2GF. Now nothing, we have to substitute the whatever given values. Quickly I will substitute. Okay, so let me write SSD is equal to, now what is V, that is 16.67 into time is 2.5. Okay, time is 2.5 plus V square is 16.67 9.67 whole square by 2 into 9.81 g f. F, how much it is? F is our, they have given, see now here F we have forgotten to calculate braking efficiency and friction coefficient of friction. So F value, here I am writing down, just note down, F value is equal to braking efficiency, that is 60%, means 60 by 100, that is 0.6 into 0.7, right? So F value will be 0.6 into 0.7, that is 0.42. okay, this is our F value. Okay, as such I have told you, you can take 0.4 to 0.35, but here we will be taking for solving this particular sum, we will take the value of F as 0.42. How we have derived it? Just we have to multiply the braking efficiency with coefficient of friction. Obviously F cannot be this much high value. Okay, F will be in this range only, 0.4 to 0.35, but still this is also okay, 0.42 is also okay, because this is given in exam. Okay, so again let me write, so this is 0.42. now what will come, plus or minus? This is descending gradient, so minus 2%. so minus 2% means it will be minus 2 by 100. so 2 by 100, can I write 0.02? okay, so let's find out SSD. SSD is equal to, so let's calculate the value. So this is 16.67 into 2.5 plus 16.67 whole square divided by 2 divided by 9.81 divided by 0.42 minus 0.04 is 0.4. So answer is 77.08 meter. So 77.08 meter. So this is we can see it is in this range of 75 to 79. So answer is D. Okay, thank you very much.